All right, let's look at this one. Find the limit of x squared minus 3x over x minus 1, and we're looking at the limit as x approaches 1 from the left. All right, when we do this one, we are going to look at I tried factoring it didn't simplify, so it's not going to have a hole in it. But do you recall what to do in case 3, where the denominator is larger in degree than and then the numerator is larger than the denominator? We actually divide x squared divided by x, multiply, change the signs, and bring down. Nothing to bring down, but we'll probably be able to divide one more time, so I'll bring down a 0. When we change the signs, I get a negative 2x, and it's plus 0. Negative 2x divided by x is negative 2, and then we have a remainder. And we were able to ignore the remainder and just know that the asymptote was slanted at x minus 2. So we have that as an asymptote, and we also have x equals 1 because of the denominator. And now we just have to figure out which side of our slashes will go. Plugging in a 0 into the original, I get 0 over minus 1, which is 0. So this point is on the graph. So that tells me my slashes go like this. Alright, that's the quick draw of that problem. So now looking at it as the limit as x approaches 1 from the left. So we're coming in to this value from the left. You see that it's getting higher and higher. So the limit as we come in from the left, oh, I asked you to come in from the right. So if you come in from the left, it is positive infinity. If you come in from the right, it is, like I did ask you to do, it is negative infinity. All right, so looking at the graph, establishing the graph will help you know which infinity we're going to get. We will end with properties of limits, and the properties of limits can be stated like this. Let me cover up some of this. Let's say that we're given the limit as x approaches c of a function is infinite, and the limit of another function as x approaches c is not infinite, it's L, it's a number. How would these combine if I added the two? What would be the limit as x approaches c of this f of x, which had an infinite limit, and this one that had a finite limit? When you add the two, the infinity trumps, so you're going to get also an infinite limit. So positive infinity. What about if you multiply the two? We're multiplying something with an infinite limit and one with a finite limit. As you might have guessed, it is also infinite. What if, that's if L, this L right here, is positive. If L is negative, then we have an infinite times a negative constant, and that would give us a negative infinity. So L can change the direction of the infinity. All right, let us look at one more. This one was adding, this one was multiplying, this one is dividing. So we're taking the limit as x approaches c of a function that has a finite limit, a number, divided by an infinite, a function that has an infinite limit. So you have something finite divided by something infinite. So if you have infinity is so large, and if you're dividing something finite, even if it's quite large, divided by infinity, it's going to be 0. So hopefully you could have jumped to that before I did. All right, an example in using these limiting properties of limits. So what's the limit as x approaches 0 of 1 plus 1 over x squared? Well, from this rule, let's see what just the limit of this would be. Since there's no x in this term, its limit is 1. So that's a finite L. And we're adding it to this term. What's the limit? That has a vertical asymptote and it goes up like a volcano. So you can see that the limit is infinity for that one. And so we have 1 plus infinity. So we get infinity, just like this rule. What about this one? This time we're looking at some trig ideas. X is approaching pi over 2, and we're looking for tangent, not of pi over 2, but tangent x. That was a mistake. Alright, so tangent, let's take a look at that. It had a asymptote here, and an asymptote here. Pi over 2, negative pi over 2, and it wobbled in a positive sort of way, the snake. So what happens to just tangent, the bottom part, as x gets closer and closer to pi over 2, it becomes infinite. So this part is infinite, but when we put pi over 2 in for x, we get pi over 2 squared plus 1, which I'm not really even interested what that is. I know it's some constant. So we have a constant divided by infinity, so we get 0. Alright, I will drop you off there, and we will work with infinite limits tomorrow. So we will talk more then. Over and out.